Section 1C, we talk about sets and Venn diagrams, and we'll primarily use sets and Venn diagrams to break down categorical propositions or interpret the language in a problem into a set theoretic or a nice diagram to help us determine whether or not the logic is valid for a specific argument. And that'll be what we do in the following section. This is just the setup for that. So there are four types of categorical propositions. And here they are listed 1 through 4. Okay, categorical proposition is really a classification of sets. In the first case, we see all S are P. So S and P are two different categories. S could be dogs and P could be mammals. All dogs are mammals, or all S are P. All right, so that gives us some idea of how two sets are related. And all four of these are different statements that we might see in problems involving logical arguments. So below, we're asked to construct a Venn diagram for each of these four cases. So in the top left, we have all S are P. So we'll represent sets by circles or circular or oval drawings within this outer box. And so all S are P means that anything that is in the category S is also in the category P. So let's write this in so we have it labeled correctly. Here's our set S, the little one inside, and here's our set P, the outer circle. All S are P means that if it's an S, then it's also a P. If it's an S, then it's also inside the outer set P. Okay, so that's how we'll interpret that. That means that the two sets one is completely contained in the other. For the second case, no S are P. I have this labeled below. No S are P. Well, nothing in S is in P. So we can draw that this way. So no S are P. Okay. It's also the same as saying no P are S. Nothing in P is in S. No dog is a bird. No bird is a dog. Right. So the third one, some S are P down on the bottom left. So this means that there's some overlap. The most general way to draw this, and that's the way we want to draw each of these, we see that this actually qualifies for some S are P. Not only are some SP, but all S are P. What this statement allows for is there's a possibility that some S are not P. Okay, so if that's the case, we want to be careful when we choose to draw this and be most general. We don't know if all the S's are contained in the P category, so we just have to keep it as general as possible. In this case, some S's right here are P as well. Okay. Some dogs are Labradors. All right, let's see. Next up, we've got some S are not P. So that's going to look very much the same as the one we just did. So all we need is to make sure that one of these sets is outside of the other one. At least part of S is outside of P. There may be some overlap. Some S are not P does not preclude some S are P. So it's possible that we do have some overlap, like right here. But to refer to the some S that are not P, that would be an element over here. So these diagrams will go a long way to help us break down deductive arguments when we see that in the next section. So to go a little further with these, let's actually use them on specific statements. So draw a Venn diagram to represent each of the categorical statements. All bicycles are vehicles. Okay, that's our all statement. One set should be contained within the other. So the outer one is vehicles. The inner one is bicycles. So we'll label them vehicles. And we'll just call this one bikes on the inside. All bicycles, everything in the set of bikes is a vehicle. It's within the set of vehicles. Usually a nice way to see this with an all statement is the first part is the little set, the second part is the larger set. That might help keep things straight. No tomatoes or vegetables. Okay, so let's make the set of all tomatoes. These are the non-overlapping sets. No tomatoes are vegetables. So these are tomatoes, and this will be our set of vegetables. Remember, not a single tomato can be in that vegetable set based on this sentence. We don't really care what these statements say in terms of reality. They could be true, false, whatever, as long as we logically and loyally write down exactly what we are reading. All buildings are houses. Okay, so that's probably not true, right? But we just follow the directions as is. We're not worried about whether or not this is true or not. But all buildings are houses. That's exactly what we're told in this statement. All we're doing is faithfully writing down this statement. So the outer one is houses. We're not trying to convert it to what makes more sense. We're reading it exactly as we see it. The first one is the little set. The second one is the larger set when we have the word all in front. So all buildings are houses. That's represented in this bottom diagram. Okay, now is it true? Well, probably not. But again, we wrote down exactly what the statement says, and that'll be useful to us in the future. A last set for Venn diagrams is to categorize counts of things, people or otherwise. So in a trial of a new allergy medicine, 120 people were given the medicine and 80 were given placebo. So of those given the medicine, 90 showed improvement, and of those who were given the placebo, 20 did not show improvement. So we've got sort of a mix of things going on here. The first thing they ask us to do is make a two-way table. Well, this is a two-way table. Now, we need to pick one column to be medicine or placebo. The other row here could be improved or did not improve. Not improved. So it doesn't matter which one we choose, but we'll say this one can be the medicine, and this one can be the placebo. And we know we have 4 different states. You could have the medicine and have improved, and then you could have the medicine and not improved. You could have the placebo and then improved, or you could have had the placebo and not improved. Okay, so let's put all these numbers together. 120 people were given the medicine, and 80 were given a placebo. Well, so we only know the totals outside of this, and it helps to write these totals down because then we can determine maybe unknown entries in this table. So total of 120 were given the medicine and 80 were given the placebo. Okay, so we've used that information. Now, what else do we know? Of those given the medicine, 90 showed improvement. Okay, 90 showed improvement here. So that being the case, that's given the medicine and improved. So there's 90 that goes here. And then of those given the placebo, 20 did not show improvement. Okay, so that's placebo and not improved for 20. Now to fill in this one, it's 80 minus the 20, the total minus the other column, and that makes 60 for this entry. For those who are given the medicine and did not improve, it's similar. 120 minus 90 is 30, given the medicine and did not show improvement. Okay. Make a Venn diagram from the table in part A. Okay, there are a couple different ways to do this. What the book suggests is the following, and I'm fine with it. It's to draw 2 circles that do intersect. And the thing you want to be careful of is if you use this method, one of these circles needs to be a row, like medicine or placebo. The other one needs to be a column, like improved or did not improve. And it doesn't matter which of those 2, but one has to be from the row, one has to be from the column. Otherwise, if we did something like, we didn't do that, we might choose this set to be the set of people who were given the medicine, and we could say, oh, well then I guess this would be the set for the placebo. This is the wrong way to do this. We're not choosing a column, we're choosing the other row entry. Well, how many people were given the medicine and the placebo? None, right? So that's not accounted for. And this doesn't get us anywhere in this diagram. Placebo would be wrong to put here unless we got rid of medicine and chose improved or not improved. The other set, I'm just going to choose one of our column entries, and that'll be the improved entry. Again, it doesn't matter which one. Now, in here, this is medicine and not improved because we're not inside the improved set. So medicine and not improved. Just for a note here, how many people are in that category? It looks like 30 from our table above. So we can list 30. So the idea of these Venn diagrams is to set up distinct regions and to be able to identify the number of people in each region. So people that were given the medicine and showed improvement, that's 90 looking at the table above. Now, people who were not given the medicine, is anybody here? This is placebo out here because it's not in the medicine circle. It's also not improved out here because it's not in the improved circle. So we actually know this. Those given the placebo who didn't show improvement were 20 according to the table. And those who were given the placebo, and this is placebo, and not improved. Oh, oops, and improved. That's incorrect. It's not in the, it is in the improved circle, so it needs to be and improved. Okay, and that count for placebo and improved is 60. Now, what we don't need to do is anything written in red here, these little bits, are not necessary in the answer. That's just for the viewer or the reader to see, so you'll understand what those 4 distinct regions actually are. Of course, the intersection right here is medicine and improved because it's in both of those sets. All right, so that's a nice way to construct these Venn diagrams. It coincides with how the book teaches it as well, and that's probably the best way to go for now. So part C, how many who received the medicine did not show improve or did not improve? Medicine did not improve. 2 different places to get this. There's medicine and did not improve because we're not in the improved circle, so that's 30. Another way to get it is to look up top the table here, get it from there. So either of these actually works. How many people who received the placebo improved? That's placebo and improved. That's here or here. So that's 60. And once we have, we're given this information at the top, all these things, we didn't know directly what these answers down here were going to be. But once we set up these tables, we were able to pretty quickly, table or the Venn diagram, we were able to pretty quickly come up with that. So that's all there is to this Venn diagram for categorical analysis or categorical propositions and for set theory problems or counting problems like this one. And in the next section, 1D or 1E, we're going to talk about deductive arguments, and we'll use these Venn diagrams even further for that. So good luck and practice these problems.